Hey, welcome to this video. So basically what we will do today, I did this recently. So it's a Midi connector with a jack Midi connector, 6.3 millimeter. And what happened is that it allows you to connect it to an Arduino without soldering. So as you can see here, it's just you have two magnets, and the two magnets are blocked between the line here. As you can see here, it's just two magnets like this with the line. But the problem is that I have some magnets that are doing 8 millimeter, like you can see here. That is quite heavy, quite large. But I also have some that are more thin, and that are doing 1 centimeter instead of 8 millimeter. And what I want to do is transform the version I did to the 1 centimeter. But to do that, I need to redo the project. As you can see, here is the last version I did with the 8 millimeter, but it's quite high compared to those small magnets here that are really 2 millimeter height instead of 4 millimeter height. And so that's the aim of this video. So if you want a tutorial of how you can do that with Fusion 360, you can follow this video. So I'll just take a screenshot here for me to remember the shape of what it looked like at the end. Up, like this. Yeah. So as you can see, I have several versions. I have this version first that I did. The cool part of this version is that you have two holes here, so you can put the the cable here, the metal cable that is conductive of the electricity here, two magnets here in the side, and the jack here. As you can see, it's important that the sphere here touch the bottom part where the magnet will be glued to the jack. And I did those to be able to hold the cable. But the problem with this version is that you have a cable that comes here and here. And so the problem is that if you make a too long cable, it can touch. If you want to do it in this direction instead of those direction. And the second problem is that here, when you bend the cable, it's really hard to bend the cable. Even a small like this, that is 0.8 millimeter, is not bendable easily on this part. So I need to do another version. And the other version is what I did just here earlier. I did a version where you put your cable here and the second one here, and there is no hole on the side. Like that, you just cut the cable, put it here, put the two magnets, cut the cable, put it here, put the two magnets, put the jack, and that's good. The rail here, it's because it allows to do this. So as you can see here, there is a version here where you put that here like this. That's another prototype I did. Okay, and there is the part on the top here where what you can do is that when you have put the cable on your small part here, just take your small piece of plastic and you do that like this. If it breaks or you want to change it, you can just slide and put another one and re-slide in. And it means that you can, if you do a lateral one, you can have like 4 here. But if you do a vertical one, like from here to here, then you can put like 1, 2, 3, 4, 5, 6 on a small distance. And so that's what we will try to do in this multi-tint version. So yeah, let's try to do that. So how we can do that? We will do a new project up like this. So what you want to do is to have two cycles that are touching each other, but you want also the MIDI jack. Oh yeah. So I have a SVG or a DXF that is representing a MIDI. It's on the GitHub online if you want it. So here, MIDI 30mm jack. I use the DXF like this, and I do it on this plane here. Yep, like this. So as you can see, this is the shape of the jack. Okay, so we want to have a full 30-degree profile. We're on this profile, the axis, we're on this axis, and ta-da, we have a MIDI jack. The idea is that the magnet must not touch the part over there, so it must be cut here. So what we will do, that we will do a new plane, like this. We'll do here small line, up, this, and here we'll do 1mm over there, 1mm over there, like this, and it's just to help us know where we put the cycle. So now here you can ask the cycle to be a 2-point cycle, like this. And here we want to do one with 1mm, but as we want it to be able to fit a bit, I will put 0.8 millimeter, just to allow the magnet to be in if the plastic is too tight. So we do the same on the other side here, this. So 10.2, this. And so here I start to see what it will give us. So now that we have that, we want a rectangular part that is around us. So let's say that we want a rectangle here, up, and we want here to have 2-3 millimeters, something just enough for the plastic to be melted, because most plastic are 0.4 millimeter, and so we want bigger than 0.4. So we'll do a bit heavier here, like this, and here. The idea is that here you will have a wall in your project, in your box, your foot, anything you want. So you will have something like this here that is blocking. So you need to let a little bit of hole to be able to let the user choose what thickness they want to the wall over there. Okay. Okay, so now that we have that, we can extract those and say that we want we don't want to do that. Okay, first of all, what happens is that if I do now the stuff, the magnet will be able to go out of the hole we will do here. So what we will try is to take the jack here and to move it a bit like this. So we need just a little part here to be able to touch the magnets, like this. Okay, so now we can extract those, and as the magnet are doing 2 millimeter plus a small cable that need to be in, we'll put 5 millimeter, and we will hide the body, hide the jack to not touch the jack. This, ta-da! Okay, so that's the part where the magnet will be. Now what we need to do is to make the upper part. And the upper part, how we will do this, is we will take here this part, and we will cut with the length of that. So let's do the upper part. Up, we create a sketch. We say from this. So now that we have this sketch, we can select the surface of the sketch. This. Up. And we will go up, 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 like this. So what we want to do is to keep here. We'll do like this. Join. And we hide the jack because we don't want to join to the hack. We want to join to this part on the bottom. Like this. Jack. So now we have a hole here, and we need to take the jack. Say we want to extract this, like this, and we want to extract it until here. And how many millimeters it does? It's 31. Okay, so 1.5, 0.3. So now we hide the body. We say that we want to join this, and does it? Ah, shit! I did shit. So here you have the history if you unlock it in your version. So I will undo what I did, because here I did a join on the other one. So it's not what we wanted to do. So instead of doing that, I will just create here sketch. This I will hide. Like this I will extract this for 31.5 millimeter. Less 31. Like this, and we have our hole. Splendid. Okay. So now that we have our hole, it's almost, yeah, no, it's not almost done. We have to do some progress, but it's not done. So now what you want to do is to have on the surface here, you want to have a hole here that that allow you to have the cable, to put the cable from the magnet. Okay, so we need here in the middle of that a small height, okay, like 1.5 millimeters, so because 2.5 millimeter, because the magnet is doing 2 millimeter and there is 1 millimeter for the cable. Like this, we do a hole of 30 millimeter, like this. So is it a good idea? Because if we do it 1.5, yeah, it's okay, like this, and we cut this like this. And what you want to do is you could stop here, but what I propose you to do is to cut until here, like this. Yeah, that's a bad idea, because as it's 1 centimeter, it will remove some plastic that you maybe need, so we will not do that. So we cut just here to be able to put the cable inside, like this. Okay. Maybe something I could, yeah, something that is very important when you do 3D printing is that maybe I could have done, so it's just, I will show you what I should not do. Maybe what I could do is to do this, like this, to have more space to put the cable. I could do that, like this. But the problem is that if you do that, when you will print, it will do 1 layer, 2 layer, 3 layer, 4 layer, and he will do here and here, there is nothing to hold the plastic. And so basically the plastic will move down and you will break your prints and everything will go wrong, and you will probably lose your pieces. So you need to have a 45 angular maximum. And in some case you can, for example, when it's a small sphere of 1, 2, 3 millimeter, it's not a problem because it will join soon enough for the plastic to not bend in the hole. So here it will be okay. That's why I tip you to do a sphere or a triangle, something that allow you to put the cable, but that will not be damaged by the plastic. Okay, so now we have the first hole for the cable here. Now we did a second hole here. Okay, so the idea is that we want the line to do like this, like this. Okay, so what we will do, we'll do a new sketch on this one, like that. We'll do a line just to have a an idea of what we are doing. So we want to go from there to there, and then we'll go from there to there, like this. Okay, save. So what you can do, I think I will try something. I'm not sure it will work. Will it work? So what I will do is to take this edit. We'll try to make it a more like this. Up 6. I'll try to make it a bit bending, just for the cable to go better in the stuff. And here what we will try to do is take a cycle and do flip, remove from there to there. So, yep, new, this, we'll do a sphere, this, of 3 millimeter, this. And I know that there is an option in Fusion, I do not remember which, but I think it is this one, that allow you to say, hey, I want this one around, and no, it will not work, it's pass, I think. This one, sweep. We say we want that around, like this one, like this. And we don't want to cut on the top, we want to cut a bit down of that. So what we'll do, we'll say that we want a new body, like this. Hop, we'll take it like this. And we will go down of 2.5 millimeter, like we did just earlier for the other hole over there, like this. And as you can see, when we will do a Boolean operation combined, we say that this one, we want to remove the volume of this one, like this. Ta-da! So as you can see, we have a cable that will be blocking the magnet over there, and a cable that will be blocked in the magnet over there. If you want to be a bit more pro, is you need to hold the cable for the cable to not go in the other part of the project. Okay, so what we will do here is to create here a 2-line cycle over there to there, and we will ask to have a node line here of 1.5 millimeter, like this. Okay, So the problem is that we don't want those parts to the bottom part. So what we will do, because here when it will print in an empty space, and you don't want that to happen. So you will go over there on the side. You will go perpendicularly to the place on the bottom, from there to there, like this. And just to be sure, I will cut. Yeah, we cannot cut. Okay, because I'm not going too deep in the stuff. So we'll make 1.54. This cut. No, not a good idea. Okay, I will go back like this. So what we want to do is to go from there up to there to there. This part is a construction path. It means that it's not affecting the shape we want. Like this. This part, it must be perpendicular to this one. Like this. Cut this part, we don't need it, but he yeah, he don't like the fact that. Okay, we'll continue the line. This up, we'll cut this part. Yeah, you're not obliged to do it like this, but I prefer to do it like this. Okay, so now you can see that we have this small area that will be this and this, that we will be able to extend like this. Join. So you need to extend it enough to be stiff, but you need to make it small because you still need to bend the cable over there to be with your finger to go over there. So this, ta-da! So now we have our two holes, the two magnets here. The problem is that if you print it like this, this part over there, if the cable is a bit too big or the plastic a bit too tight, it could break the plastic at place you don't want it to break. So you need the last step here is to take this surface here, like that. You ask to create a rectangle from the center. This. You go on the top of this part. Can I? Like that. You take your rectangular, center rectangular, like this, and you will break a bit over there. Just enough to be able to do that with the plastic, but not too much because the jack need to stay in the hole. Like this. And up, extract this for 31, less 31 millimeter. And as you can see, it's not 31 because we are a short piece of the project, so it just over there like this. Hopla. Ta-da! So basically here, if I'm not wrong, the idea of the project is, no, there is a last step that we need to do. The last step is that if you do that, you will need to glue it to the plastic, and you don't want to glue it, you want to stack it in the plastic. So to be able to stack, you need to add a little plastic in triangular way. So we will select this, like that. We'll do a rectangular here to here, like this. Now we will ask to do that for 1.5, for example. That for 1.5, like this. And now you can take this and this, and you can move it till there and do a join like this. And ta-da, we have the idea of the project, and that's basically all we need. But I know it's a bad idea in the design, because when you want to read it later, it's boring when you have shape. But I really like having a bit of round shape. So we'll use the feeder here, and we will say that here we want feeder. We want this border, this border, this border, this border, and this one, 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 and this one. We want a shape of 2 millimeter, 1 millimeter. Cancel. So we want to bend this, this, this for 3, like this, maybe for 5, like this. Okay. Now we want to bend this and this for 3, like this. And the other one is not obliged to bend them. If you want, you can. Not sure I should. So yeah. Ta-da! Is there a way to make it less corny? Like this. Ta-da! And are we end here? Yeah. So basically, we are at the end of the idea, except if you want to do the holding part. So maybe I will show this part. And yeah, so the holding part, you do this, as you can see, can we use the last? We will use this one. So this one is the part we used previously. So now what you just need to do is to edit it like this. So you want this part and this part to have something like here, like 0.5 millimeter. Why you want to have a bit of place? It's because you want the plastic to have enough space to go and not force like hell to be in. So like this. We'll do the same here. 0.5. This. Plus, you have to remind that when you print your plastic, the base will have elephant's foot, so it could take a bit of distance here and not be finished exactly where you want. So you need to have a bit of space over there. Okay, so now we can edit still. Okay, so now what we can do is take this here, like that. We'll go until here. up. So how many distance I need? Say like this. Up. Yeah, I'm not precise here. It's not good. So center rectangle. This here. Now what we need to do is to go fetch the top here, go parallel to until here, cut here, now here parallel and perpendicular to this one. We finish this one like this. Okay. Here, do we have everything we need? Yes. So we end the sketch. And we want to extract this part, and this part until up over there maximum, because we want to be blocked by this. Okay. And we want that to be a new body like this, and ta-da, we have the holding part that will be used to block the plastic we want. Now yeah, in this project the problem is that I won't do that, but here the problem is that when the user will enter the jack here, you can see that it pressing up a bit backward, and so it could here poof put the stuff outside. So I'm not sure how we can fix that except by having a small piece here that block, like you can take a small plastic and you put it over there to block, or just put a glue point over there, just because there is almost no friction to enter the jack in it. But you have to take into consideration that if it's a bit loose, then it can move out of that. So think about it when you do it. For my part, I still don't have the answer of how to fix that. So I will have to think about it. But I will find ways. And so yeah, the last step I want to do is to block here. So as you guess, I will just here say that I want a rectangular from there up from there to there. Yeah, not good. How can I? Maybe what I can do is go from the bottom part like this and say that I want this part over there, and I want to do a rectangular from up there to there. I want a rectangle here of 2 millimeter. And what maybe we can do is So I try something. I'm not sure of what I'm doing. Like this. And what we try to do is a small part over there that go behind here. This. Yeah, and we extract this. Yeah. So what happened is that in other projects, what I use is a small sphere that you can buy at IKEA or in metal sphere, and where I don't have one, I just print the little piece of plastic. And so what happened here is that we will just here say at the end, at 1 millimeter of the end, 5, we want a sphere, 2-point sphere like this, of how many millimeter? I think it's 6 millimeter, the one I used. So this distance, sketch dimension, wants, yeah, he won't let me do that. So 0.5, 6, this, and if you need the small piece of plastic, what you do is here 5 millimeter, this. Okay, and so what we will do is extract this part and this part for this distance, this as a join, but we will hide this body to not join it accidentally. Ah. 3.5. Yes, 3.2. Problem is here that we still need him to slide. So this, yep. Here up, you can print something like this. So if you have something of 6 millimeter that you can put in, good for you. Else you just print a 3D part like this, and you block it behind the 3D model. And so you need to do a hole here for in your project to really fit that in. Yeah, bad idea, shit. Because it will block the cable parts. So we'll see if we cannot do it like this. Like this, because you need the cable to be able to go over there. So yeah, and so if we do that, we need also to do a bit over there, and do there like this, and ta-da! That's basically the my project to be able to connect jack Ah, shit. Okay, forgot one piece. Ah, no, it's okay, it's okay. Because here, basically, I was saying shit because ah, nobody. At one point, I asked to join this part, so I need to find where. So rename connector name connector holder. Okay, still there, and here we lost it. So edit. Dun, 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 dun. This extrude over there until there, but in without the connector. This like this, and block this. Check. And ta-da! And why we don't have a hole here on the bottom? It's because the holder need to the magnet need to be in the connector, but we don't care that the magnets as they will stay over there in the plastic. We don't care that it has a hole under it, and it's better like this. You're sure the magnet don't fall anywhere. So ta-da! And if the cable move out of the magnet because you pull it a bit too hard, you remove this part, you remove this, you unload the magnet, put the cable, reload, and you are done. So I hope this tutorial was useful to you, and that you can use this stuff in your project. Don't hesitate to send me a beer as donation for thanking me on the project. It's an open source project. There's no license on the project except the Be Aware license. Have fun, have a good day, and see you in the next video. Bye.